In this video, we're going to be looking at solving trigonometric equations using substitution. So if you look at this, you will notice that there's some square involved, right? In fact, it should look something very similar to what you've seen before. So I am talking about our quadratic, right? Ax squared plus bx plus c equals 0. Yes, quadratics comes back to haunt us. Now, what can this do to help us? Well, if you notice that this equation kind of resembles the quadratic equation, but not exactly, but we can manipulate it to look like it. In that we can, let's say, let cosine theta be x, right? So this is where the substitution comes in. Well, that means that cosine squared theta is going to be x squared. So I can rewrite my expression. So now it becomes x squared plus 3x minus 1 is equal to 0. So now it kind of breaks down to a standard quadratic equation that we need to solve. Now, if you recall, we can solve a quadratic by using our quadratic formula, or we can do factoring, we can do by completing the square. So we have quite a bit of things at our disposal. But I always tell students to focus on the quadratic formula, because while sometimes factoring may be a little bit of a pain, using the quadratic formula never fails. But let's see, even then, can we factor this? We need two numbers that multiplies to give us a times c, that's to give us 3. There are no such two numbers. So we would have to do the quadratic formula anyways. Now, if you recall, the quadratic formula is, if you're given ax squared plus bx plus c equals 0, well, quadratic formula tells us that our solution x is going to be equal to negative b plus or minus the square root of b squared minus 4ac, right, all over 2a. That is going to be our solution for x, okay? Now, what we need to identify is what is a. So if you look here, let's see, a in this equation is going to be 1, or b is going to be 3, and c is going to be negative 1. So we'll plug this into our quadratic formula. So we have negative b, so it's going to be 3, plus or minus the square root of 3 squared minus 4 times a, in this case is 1, times c, which is negative 1, all over 2 times a. And so a is 1. I like to use parentheses because you never know. All right, so what does this give us? This gives us that negative 3 plus or minus, this is going to be your x, so 3 squared is 9, minus, so these two negatives, they become a plus sign, and so 4 times 1 is 4 times 1, so that's plus 4, all over 2. Right, so we can keep simplifying. This becomes negative 3 plus or minus the square root of 13 divided by 2. Okay, so we know we can split these. And so these become what? Negative 3 plus the square root of 13 divided by 2. Or, let me go a little bit over here. This is going to be negative 3 minus the square root of 13 divided by 2. So now let's come back to the fact that this isn't the original equation that we were solving, right? Remember, the original equation involved cosines. So we did this substitution where cosine theta is equal to x. So this here, recall that this is what we solve for. We solve for x. This is our x. Or these rather, are going to be our x values. So remember, cosine of theta is going to be equal to these values then, right? Because if we're saying that this is x, negative 3 plus root 13 over 2. That's first x. And then we're saying that this is going to be negative 3 minus root 13 over 2. So if we're saying that these two are x, well, it also means that we also said that what? If we go back in the beginning, we let, right? Remember, we let, let's see, change the color just to bring this to your remembrance here. This is what I'm talking about. We let x be equal to cosine theta. So that's what I'm going to be pulling back here. So since x is cosine theta, well, that means that I'm plugging back in. So cosine theta is equal to negative 3 plus root 13 divided by 2. And likewise here, cosine theta is negative 3 minus root 13 divided by 2. Now, at this point, there's a trick that we use. If you want to get theta out of a situation like this, I shouldn't say that, but if you're solving for your angle theta, the trick that we would use is the inverse, right? You'll take the inverse of both sides. You can write it like this if you'd like. And you would say, well, we're doing cosine inverse, okay? So here, the cosine inverse would cancel, and so you'll just have theta is equal to the inverse. So cosine inverse of this whole thing, negative 3 plus the square root of 13 divided by 2. That's for that side. Or, should be a comma here, or theta is going to be, so we're again taking the inverse of both sides. So that means theta is going to be cosine inverse of negative 3 minus root 13 over 2. And so you should have a function on your calculator that gives you the value of theta once you just plug it in. Okay, let me rewrite this here. Okay, so yes, now if you were to go to your calculator and you type the first thing in, get cosine inverse, of negative 3 plus root 13 over 2, you should get something that says error. Okay, so this is actually going to be an error here, all right? Because this is going to be out of range for what we're looking for, all right? Now, if you look at the next question, or well, not the next question, but the next answer choice, let's see here. This answer choice here, well, you're going to get that theta is equal to 1.26, right? That's what it's going to give you for theta. Okay, so now if you notice the solution here, when we solve, or what the theta, or well, let's just say the angle inside here, cosine inverse of this negative 3 minus root 13 over 2, that's going to actually be a negative value, right? Because it's going to be negative 3, square root of 9 is 3. So it's going to be around negative 3 minus a 3 point something. So negative 3 minus 3 point something divided by 2, right? So this is going to be negative 6 point something divided by 2. So this is going to actually be a negative value. So actually this angle is going to be in the fourth quadrant, with the terminal side of this angle on the first quadrant, right? And so if we really want to know what the actual angle is, we can use this reference angle here, right? To this little reference angle here to give us the actual value that we're looking for. And to do that, we would do, or to figure out what this reference angle is, we would do 2 pi minus that 1.26, okay? And so if you do 2 pi minus 1.26, well, that will tell us our theta that we're looking for here. The solution, the second solution, is going to be 5.02. Okay. Now, let's look at another example, or another question that we can use the substitution method to solve. Here we have 2 sine squared theta minus 5 sine theta plus 3. Now we want to, again, we're going to use the U-Substitution. And some people say U-Substitution. As you saw before, I just used X. It's totally up to you what variable you would like to use. Alrighty, so let's say, well, let X be equal to sine theta. Well, that means for us that X squared is going to be sine squared theta. Now, if we are doing this substitution, our question or equation now becomes 2x squared, write that out, 2x squared minus 5x plus 3 equals 0. Now, this question, I think we can actually factor. So since we used quadratic formula before, we're going to factor here. Now, in factoring, recall, we have to identify if we have, let's say, ax squared plus bx plus c equals 0. Well, we can identify our a. So in this here, a is going to be 2. B is going to be, in this instance, -5. And C is going to be 3. So now that we've identified A, B, and C, when we're factoring, we're looking for 2 numbers that multiplies to give us A times C. So we want a product of A times C. And in this case, that's going to be 2 times 3. And then, which is 6. We need the sum, these 2 factors. When we multiply them, we get 6. But when we add them, we get B, which is going to be -5. And what do you know? The numbers are in front of us. Because the number 2 times 3 is 6. And then, we'll have to take the negative of those, right? So -2 times -3 will give us a +6. And then when you add those, you will get -5. So I'll come back to my equation and let me just rewrite it because I like to show the split that happens. So I'm going to rewrite this, and this is not your traditional way of factoring. And I will say this, you can factor many ways, but this is how I like to go over factoring. So you have 2x squared, and so we're going to split this 5x. And so this 5x is now going to be using these 2 factors that we just discovered. We said -2 and -3. So this is going to be -2x minus 5x. And so here, just notice that we're not changing the value of the equation. We're just rewriting it to make life a little bit easier for ourselves. Okay, so here we have 2x squared minus 2x. So now we can factor by grouping is what we call this. So I can see here that 2x is common to these 2. Right? And so let me draw this arrow here so you're following. So if I pull a 2x out, this becomes just x. And then here I'll have minus 1, right? Because you're like dividing. Now, whenever you notice that there's nothing in common, you can always pull out a 1. But since I want to have a negative here, let me see. That shouldn't be a 5. That shouldn't be a 5. That should be a 3. There we go. It should be 2x minus 3x because we're using these two numbers. So minus 2x and minus 3x. There we go. So we can actually pull out a 3 here. We can actually pull out a 3. So this would be plus a positive 3. And then I'll have here x. I want a negative 1. So I should pull out a negative 3. That's the beauty of factoring. You can manipulate it to look like what you want it to be. Because ideally what I want is for these two things that I'm about to write in the parentheses, I want them to match so I can continue my factor by grouping. Earlier I had a positive 3, but if I did that, I would have a positive 1. And I don't want that. I'd have a negative x and a positive 1. I want a positive x and a negative 1. So that's why I changed it to negative 3. So now this will give me a positive x and a negative 1. And so these two things are matching. So I can plug those out. So this becomes x minus 1. And then I have left over 2x minus 3, right? If you pull those out, if you can kind of slash them out, something like that. And this is equal to 0. So now I have two expressions that are equal to 0, but I can plug back in because remember, what did we use as our substitution? We used this x. So let's use that back and we're going to plug that substitution back in. So this is going to be sine of theta minus 1 times 2 times sine of theta minus 3. And we're saying that these are equal to 0. Now, the product of two things are equal to 0. That means that either one or both of them are equal to 0. So what do I mean? So that means either sine of theta minus 1 is equal to 0 or 2 sine theta minus 3 is equal to 0. Now, we can actually solve this. So if sine of theta minus 1 is equal to 0, so what does this give us? So we have sine of theta is equal to positive 1. If you add 1 to both sides, right, this is going to be positive 1. Now, recall here that we're trying to get theta. We want to get theta by itself. So we, again, can use the inverse. So you'll find that the inverse, that's going to be very important here. So if you're trying to get theta out, we're going to take the inverse. So this means you can, like I did before, you'll do sine inverse on both sides. So that will give us theta here is equal to sine inverse of 1. And so the way I like to express this and say, hey, if you're looking for the theta in which sine inverse is 1, you're thinking, well, what theta, what angle, when you look in the unit circle, what angle has a sine or a y value of 1, right? And if you think about it, if you're on the unit circle, when y is 1, that's going to be up here, right? Because this point here is 0, 1. And so that's going to be for us pi over 2. So that means that theta is equal to pi over 2. Okay, so that's how you would solve that. All right, and that's the only theta that's going to be 1 in the range that we're looking for, where theta is in between 0 and 2 pi. Now let's look at the other solution. Here we have 2 sine, so we're looking at this one here, 2 sine theta minus 3 equals 0. This means 2 sine theta is equal to 3. And so that means sine theta is equal to 3/2. Now, remember, in order for us to be able to take the inverse, we have to be, our range has to be between -1 and 1. And for us, this is 1.5. So this is not, let's say, not an element or not in this -1, 1. And so since it's not where we need it to be, we cannot take the inverse. So what that means for us is that there's no such theta. So you would say there is no such theta, or you can just say that's never going to be equal to each other. So your only answer is going to be when theta is equal to pi/2. And so this is how you can use substitution. When you have an equation that has some similarities or looks like it can be written as a quadratic, you can just use U-Substitution.